I want to start out addressing a question that Gwen brought up. She was talking with her family, and they were talking about how square feet is not exactly the same thing as feet squared. And that is true. Both can be used when we are counting the area of something, but there is a difference. And I want to go over that difference to make sure that we are using the correct math language. Harper.
Title.
Yes, this is your title.
Where's all the
All right, so we have been using the words square feet and feet squared, square unit and unit squared interchangeably. And there are times when that is true, but there are times when it's not true. Kind of like saying a rectangle is a square, but is every rectangle a square? No, so sometimes we can't use feet squared or unit squared and that be correct, but it's not going to be every time. For third grade, we are focused on counting the squares inside of a shape. So this shape, if you haven't drawn it in your notebook, go ahead and do it. This is a 2 square, I'm going to assume feet since we're counting feet, by 2 feet. Hang on one second. That means my area is going to be 1, 2, 3, 4. 4. I'm counting squares, so I'm going to put square first. Square feet. I would like us to only use that notation in third grade. The other is mathematically correct. However, we weren't always using it in the correct way, and I want to make sure that I don't confuse you down the road. So from here on out, we are only going to use square and then our unit, whether that's foot or centimeters or meters or miles or units or whatever it is.
So do we go back in the notebook and erase if we wrote the
If you want to go back in your notebook, I'll give you 30 seconds to go back. And if you have anything where it says unit squared or foot squared, this is not mathematically incorrect. This is real. It just might not be in the right way. So if you just want to put an X over top of it, you can. Thanks, Siri. Yeah. If you want to put an X over top of it, you can. But I'm not worried about it. Just moving forward, we're always going to do square and then the unit, okay? Yeah. All right, ready to move on? Yeah. All right, here's our new subtitle. This is the real question we're going to be looking at today. The first one, I just want to make sure we're using the right language. This is the question we're going to be thinking about today. How can I determine the area of a shape without tiles, without squares? The last couple of times we've been looking at shapes. We've been building them with our square tiles. We have been counting the squares on the inside. What if we don't know? What if we don't know, or we don't have tiles in which to do that? First thing I want you to do, though, circle that word determine. Great, write it. Then circle the word determine. It's kind of a weird place to see determine. We might not have usually seen that word there. Typically, if we see the word determine, we're thinking of someone being determined. What does that version of determine mean? How can I determine the area of a shape without tiles? What does determine mean in that sentence? Any ideas? Sean, you think you might know it?
How can you solve?
Yeah.
How can you know the area of the shape without tiles?
Exactly. We got solve, maybe even figure out. Both of those are great synonyms. Awesome synonyms. So when it says, how can I determine, Lincoln, I'm missing a math notebook. Where is it? Oh, can you put it on your table, please? Thanks, love. I am talking about figuring it out.
Does that say save?
I have solve. So that's the word that John just gave us. And then I wrote figure out as well. So I know what's that?
Is there like any other meanings for figure out instead of like solve?
Probably. Lots of words have multiple meanings. Are there any ideas? Any ideas of how you could do this? I'm going to write this next part in red. You do not need to write down what I write in red. Got it? Awesome. Shelby, what are your thoughts? How do you think I could do that? Okay, so if I use a ruler, maybe. Any other ideas of how I might be able to find that inside area without using tiles or squares? Will, you got some thoughts?
I don't know, maybe estimating?
Okay, so maybe we might just use some estimating. Michael, you got some ideas?
Like you could use an array to just fill it all in and then count it.
Okay, so maybe we would use an array. John, you got some ideas?
Measure the outside of it, and then Will said maybe estimate the inside of it.
All right, so that's kind of a combo of what Shelby said and Will said, because Shelby said use a ruler, maybe estimate from there. Is that what you were thinking, Devin? Gwen?
For the example we did for the square feet versus feet squared,
Mm-hmm.
we drew a 2 by 2,
Mm-hmm.
but the area was 4.
Mhm.
2 plus 2 is 4. 2 times 2 is 4. So is that how? Probably.
Can you give me some more thoughts? Because you just told me an example. Like, what were we doing there?
I mean,
I think I know where your brain is going, but I want to see if you can explain
we
it.
didn't actually use the tiles in it. We didn't count them necessarily.
Okay.
There was 2 feet, 2 feet, like 2 feet is like the length, 2 feet is the width.
Mm-hmm. So this sounds like similar to what Michael was saying. Make an array, and then we can use multiplication.
Yeah.
Is that what you're thinking?
Yeah.
All right, this next shape that's going to come on the screen, I want you to draw it in your notebook. Don't draw it gigantic, because we're going to do a couple of shapes.
Multiplication? Is it already gigantic?
All right, so we've got a 3-foot shape by 7 foot. Go ahead and draw that shape in your notebook. It does not need to be gigantic. Make sure you label the dimensions. Raise your hand and tell me, what is the length of this shape? What is the length of this shape? We've talked about words like length. What is the length of this shape? That's not a lot of hands.
What's the length?
What is the length? That's all I want to know. William?
Like foot?
So length, that would be the unit. I want the length. What is the length? I love that I see Sean looking back at his notebook because he knows the answer is in there. We did write it down. If you're just sitting there doing nothing, Lincoln, length?
7 feet.
All right. Length is just how long it is. Lincoln said 7 feet is the length. Sure. Could 3 feet be the length?
Yes. Yeah.
Yeah.
It's both.
What's the width? 3 feet. What's the width?
Wait. Shouldn't it 7 feet be the
7 feet is the long side? Yeah. 7 feet is talking about how far this shape is from here to here. Is 7 feet. Does that make sense?
Yeah, but I feel like it would make more sense if it like would go on the other side because from that side to that side is also
Oh, you mean if we labeled it down here?
like on the side.
Here?
Yeah.
Well, this is not going to be 7 feet.
No, like if you go from that line to the other line, it's still 7 feet.
From here to here?
Mhm.
Yeah, you could label this 7 feet if you wanted to.
This number.
You could label this 3 feet. What's the width? Parker, what's the width?
The width is 3 feet.
3 feet. Could you say the width was 7 feet?
Yes.
Yes. Just know that normally, Mason, when people say the length, they want to know what's the longest side. Yes. No. If we're looking at this shape, how do you think I would figure out the area? I do not want to draw tiles. Yes, I could, but I don't want to draw tiles in. How could I figure it out? What? Alright, you're on the right track. These boxes are not going to be 7 feet and not going to be 3 feet, so we're not going to label those. But you're on the right track, Victor, in thinking that there are boxes on the inside, and we can think about how they would look. If I was creating this with my tiles, I know that I would line up 7 tiles this way, because that's what my length is. 1, I'm writing, that means you're writing 2, 3, 4, 5, 6, 7. I would have 7 tiles lined up. And then going down, I would also have 3 tiles. We're just going to pretend those are nice, even squares. Now notice I did not fill in my entire shape. Because we know what this looks like. What does this remind you of? We've seen this before. Mason?
Fractions.
It could be fractions. We're splitting up a shape. One way to think about it, sure. Michael?
A half array?
A fast
Fraction.
array. Do you see the fast array?
Yeah.
Yeah, this is a 3-foot by, this symbol can also mean by,
And time.
and times, and groups of, 7 foot. This is a 3 by 7 foot rectangle. There's a reason we use that symbol that we know for multiplication. Because I can use multiplication to figure out my area. Yes, Will? If I were to draw those boxes in, how many boxes would I end up with? How many boxes would I end up with? What is a 3 by 7? I see lots of hands. We have all learned multiplication. 3 by 7. Start with 2 by 7 and add another group of 7. Brayden? What is a 3 by 7? Okay, Shelby? 21. So the area of this, we just figured it out, without having to count, is 21 square. What was the unit I was using?
Feet.
Feet. I'm using feet. Unit is what I'm measuring with. I'm using feet. So I've got 21 square feet. Sean?
Can you measure it differently by doing 7, 7 is 14? And then 3 plus 3 is 6, that's plus 14 is 20.
So will that work? Nope. Nope. Alright, let's look at another shape. Make sure you've got this written down. Make sure you've got the area. Lincoln, get that off your head, please. Alright, let's look at this shape. This is a 4-inch by 4-inch rectangle. I could also say this is a 4-inch by 4-inch square. It is a 4 by 4.
4 inches. Hey, yo.
What could be a way to solve the area of this shape without putting in any tiles. I could draw all those tiles, that would work. But how else could I figure it out without having to draw in all my tiles?
Do the thing we did on the
What
last
could I do? Sean? Nope. No.
So you already know that the 4x4.
Yep.
So you can write that. So and then it's a 4x4. And then 4 times 4, 16, so 16 inches.
Awesome. So we've got 4 on the top. I know I also have 4 on the side. That looks just like a fast array. Because it looks like an array, I know a shortcut. And that shortcut is called multiplication. Bladen, I'm writing. That means you should definitely be writing. When we see arrays, we know we don't have to count them anymore. We can use a faster method by grouping them, turn around Mason, and using multiplication. Well,
I was just gonna say, that sort of reminds me of a Rubik's Cube since it's like 3x3, a 4x4, 5x5.
sure. And now you know how to find the area of one side without having to count them. Could you count them though?
Yeah.
Sure. That will still work as a strategy. Sean, what?
I thought of another way of doing it.
How would I write the area? How would I write the area? Devin?
Mine.
16 square, what? Nope, look at my units. What is it? Inches, very good. I was using inches as my measurement this time, so my area is 16 square inches. Both of those, I could use a fast array. That was pretty easy. Let's try this new shape. See if we can figure it out.
That's a triangle.
Draw it. Draw it, label it.
By yourself?
I said draw it and label it. You can draw and label by yourself, yes.
I'm gonna get 3D shapes until
Does this look like it will have a fast array?
No.
So if there is no array, does that mean I'm going to be able to just multiply 3 times 3 and figure out the area?
No.
No. No multiplying sides.
Is it because of the points?
Yes, because these are not squares, are they?
No.
That's
It's
like
square corners.
part of a square. And remember, when we're finding area, we're counting square units. So if we don't have squares on those diagonals and in those corners, those are going to be really weird for us to count. Yes, you can find the area of a triangle. No, we're not going to do it right now. Basically, if I have a half of a square and another half of a square on this side, a half plus a half will equal my whole square. It gets much more complicated like that. Does that make sense?
No, it doesn't.
So in third grade land, we're not worried about areas of triangles because we are only looking at areas with an array. That's going to be the important part. So let's go back to our original question. Go ahead and rewrite this as either a new title or a new subtitle. Go ahead and rewrite this question as a new title or a new subtitle. 4 minutes of silent lunch.
Do we do it again?
No. Alright, we just learned a really nice strategy as long as the shapes are rectangles or squares, in order to find the area if they didn't fill in our squares. How did we just figure out those two shapes? They had no squares on the inside, but we figured out the area. How did we do it? How did we do it? Yeah, look in your notebook. We just did it. How did we do it? None of those two shapes had any tiles on the inside. You didn't have squares. Brayden, how did you do it?
We looked at the length and width of the shape
Uh-huh.
and then made that amount and then thought of that amount times the number of
We used the length and width to make a fast array. That's what we did. We made that fast array using our length and width. With our fast array,
we write that.
yes, I'm writing, that means you are writing.
We said something to do.
Only the one time that I told you that I was writing it. Because I've made a fast array, I know that I can skip count or use a shortcut known as multiplication. Sean, you're going to have to wait. If a shape doesn't have an array, can I use multiplication?
Yeah.
If it doesn't have an array?
No.
No. An array is just a way to skip count. So if there's not a way to skip count, I can't use my equal group strategy of multiplication. Sam is entering a poster making contest. The rules state that he has to create a poster with an area of less than 10 feet. The poster that Sam created was 4 feet by 2 feet. What is the area of Sam's poster? Does his poster follow the rules of the contest? What am I counting? What am I counting? I'm going to read it one more time and then I need lots of hands to tell me what it is that I'm counting. Sam is entering a poster making contest. The rules state that he has to create a poster with an area of less than 10 feet. The poster Sam created was 4 feet by 2 feet. What is the area of Sam's poster? Does his poster follow the rules of the contest? What am I counting? Devin, what am I counting? I'm counting something with feet. Definitely counting something with feet. Michael, what am I counting?
The area inside the poster.
I need to know the area in feet. What could be my first answer sentence? Because I've got 2 questions that use 2 answer sentences. Shelby, what do you think my first answer sentence is going to be? Let's look at our first question. It says, what is the area of Sam's poster? So do we ever fill out our answer sentence when we're first writing it? Okay, so let's leave a blank. The area, I'm writing, that means you were writing. The area of Sam's poster is blank, and then Devin told us we're counting feet. But we're not just counting random feet, we're doing area. That means we need squares that are feet. Square feet.
You just write the SQFT.
You can. Yep, you can shorthand square feet. You can write when Sean comes back.
But we can't write
So you can write square, you can write SQFT, that's fine.
we just can't write the FT2.
Not for this problem, no, it doesn't make mathematical sense. Alright, let's look at the second part of this question. The second question says, does his poster follow the rules of the contest? What would be the answer sentence for that? I'm not asking you to answer it. I'm asking you to tell me what's the answer sentence. When?
Sam's poster blank follows the rules of the competition.
Perfect.
Like does and doesn't.
Exactly. Gwen's thinking I'm going to leave a spot to either say does follow or does not follow. Sam's poster blank follows the rules. Alright, I figured out what I'm counting. I'm counting squares that are 1 foot by 1 foot, square feet. I know that I have my answer sentence ready to go. Now I need a model or a picture. What could I draw? What could I draw? Harper?
You could draw a poster that follows his poster's feet and then measure the inside with a fast ring.
What shape are normally posters, Harper?
Squares,
They could be squares
rectangles.
or rectangles. Are posters usually star shaped?
No. There's usually
Are
stars on
posters
them.
usually trapezoid shaped?
No.
No. And 4 feet by 2 feet gives me a really good clue. Is it going to be a square shaped poster?
Yeah. No.
Wait,
4 feet. 4 feet.
And
Like,
sides.
no, 4 feet should be like that.
Shelby says no, because I'm going to have one long side that's 4 feet, and then one short side that is only 2 feet. Does that look like the beginning of a square? No. No, it's going to be a rectangle. So here's the poster. Yep, you're drawing a rectangle poster. You're making a model. And I'm going to label my dimensions. It told me in the problem he has 4 feet by 2 feet. So I've made my poster 4 feet by 2 feet. Could I draw in those squares?
Yeah, if you want
Yes, I could, but we just learned a faster strategy. What was our fast strategy? Devin? A fast array. What would be the equation that goes with my fast array, Devin? Yeah, 4 feet times 2 feet. What is 4 feet times 2 feet? Devin, you're on a roll. 8 feet. Do I have enough information to fill out my answer sentence?
Oh, yeah.
Yeah. Lincoln, the area of Sam's poster is 8.
Square tiles?
Not tiles, square feet. We were using feet on this one. We know that it's 8 square feet. We just did that fast array. Does his poster follow the rules? Raise your hand to tell me, don't yell out at me. Does his poster follow the rules? Henley, how do you know that? Yeah, The rules say that area is less than 10 feet, and his area is 8 feet. So Sam's poster does follow the rules.
I wonder what his poster looks like.
I don't know.
Maybe it says
I'm not sure.
Maybe it has a
Nice. All right, we're gonna work on one more, and I'm gonna give you some time to write an answer sentence and draw a model before I go over it with you. So I want you to try this one on your own. The reason being is you've got 3 of these tonight for homework. I want to make sure you know what you're doing. So go ahead and give it a try on your own. And if you get stuck, that's okay. We're going to do it together. All right. It says, Jordan wants to paint one wall in his room blue. The wall is 9 feet tall and 6 feet long. What is the area of the wall he wants to paint? Answer sentence first. Answer sentence first, because you need to know what you're counting. Then you can draw a picture to help you figure it out. What am I counting? What am I counting? This should have been your answer sentence. Shelby, what am I counting?
How much length is in the wall?
Not the length of the wall. Nope, I know the length of the wall. It tells me in the problem. What am I counting? Emily, what do you think I'm counting? I am counting square feet. I have to fill up that wall with feet in order to figure out the area. If you don't have an answer sentence, you can write this one. The area of the wall is blank square feet. I know that I'm using feet because they measured the wall in feet, and I know that I'm using square feet because I'm filling up a whole wall. I need those big foot squares.
I wrote the wall Jordan wants to paint has an area of blank square feet.
Perfect. All right, next we need a picture. I saw a lot of pictures in notebooks. Perfect. If you didn't label your picture, well, I'm sorry that my teaching is interrupting your reading. Should be 9 feet by 6 feet. From here, what can I do? I have a couple of options. What can I do once I've drawn a picture and I've labeled my dimensions? Layden? Which is what? Okay, how am I going to do that, Layden? This a minute. Run this a minute.
By Miss Miller. Miss Miller. Miss Miller. Okay. Miss Miller, are you talking about me?
I am now. You can have a minute.
You could probably not this, but if you go back into your notebook, you can see the other ones like 5 feet and 8 feet and 7 feet.
So I already have the dimensions. It's 6 feet by 9 feet. I already know that.
The total?
So how do I figure out the area? What's on the inside of that wall?
How long is it?
I know how long it is. It's 9 feet long and 6 feet wide.
Yeah, and also measure.
I need to know the area. How do I figure out the area? That's what I'm asking. Michael, how can I do this?
You multiply 9 and 6
Why do we multiply 9 by 6?
to figure out the area of the wall.
How did you know to multiply?
Because if it's like if it says like 9 by 6,
Mm-hmm.
then it's like there's nine either that way or that way.
Yep.
And then there's 6 either that way or that way. So,
Yeah. Put on your X-ray goggles. Put them on. Look at our wall. I want you to imagine that there are tiles now on that wall. 9 going up and down, 6 going across. Can you see that array? Yes. Take your goggles off. We are not going to draw boxes. Will that work? Sure. Sit up. We are not drawing boxes though. If you drew boxes, fine, but we need to get away from that. We need to start using our other math ideas to help us. Michael's right. We have a 9 by 6 array. I'm not really good at my 9s or my 6s. But I do know that 9 times 5 is really close to, 9 times 6 is really close to 9 times 5. What is 9 times 5? Oh, I should see like every hand because I know you know how to skip count by 5. 9 times 5. Bella? 45. Oops. I got 9 groups of 5, and I really need 9 groups of 6. I need another group of 9. $45 plus my next group of 9. How much is that going to be?
Oh, I don't have to do this.
Okay, we'll leave it off the Mason?
It's looking for.
54.
Never mind.
Is my answer 54?
yes.
No. 54 what? Square feet. Square feet. It is not just 54. I need something else in there. It's not 54 puppies. It's 54 cookies. I need to know what it is that I'm counting. In this case, I am counting square feet. On your homework tonight, I do not want boxes. I want you to practice using what you know about an array to help you. We are well beyond drawing arrays, drawing out our boxes. We can use multiplication strategies to figure that out. Does that make sense?
Yeah.
Yes, ma'am.
So far, so good?
So far, so good.
Michael, what you need?